Hello and welcome to York Observatory's weekly TeleTube broadcast, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We are broadcasting live from the Alumni Carswell Observatory located at York University in Toronto, Ontario, Canada. York YouTube broadcasts every Wednesday night at 7:30 p.m. local Toronto time. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle at York Observatory and on Facebook at Alumni Carswell Ops. We would like to inform you about the opening and call for applications for the Summer 2023 Astronomer in Residence program. This program is a collaboration of the Alumni Carswell Observatory with Killarney Provincial Park to host astronomers in the certified dark sky site of Killarney. This is to lead in-person presentations and shows using the park's observatory. To learn more about the program, its requirements, and the application process, visit our website at yorku.ca/science/observatory/air. Good evening, everyone. I'm Maheen, and I'll be one of your hosts this evening along with Dorsa, Marianna, Camila, Zena, and Pouria. Tonight, we will be talking about Jupiter's 4 Galilean moons. Before we get started, I would like to mention that the observatory at York campus is in Toronto, and we would like to welcome you all to our show and to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence in the traditional territory of many indigenous nations. The area known as Takaranto has been taken care by the Anishinaabe Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. It is now home to many indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalizing our knowledge in this area. Welcome again, everyone. Before we get started with our main show, we want to give you a little update on what you can see this coming week. Moon is currently in a waxing crescent phase with an illumination of 4%, which makes it a good opportunity to observe other bright objects. Some of the stars you can observe tonight include Sirius, Capella, and Betelgeuse. Sirius is the brightest star in the night sky. It is part of the constellation Canis Major. A tip to find Sirius in the night sky is to look for the constellation of Orion. If you think of a line passing across the middle stars of the constellation of Orion and look towards the east while following this line, you will be led to Sirius. Capella is the brightest star in the northern constellation of Auriga with a magnitude of 0.24. It is the sixth brightest star in the night sky and therefore fairly easy to spot. Betelgeuse is a red supergiant star. Supergiants are among the most massive and luminous stars, and Betelgeuse is one of the largest stars that can be seen with the naked eye. It appears to be orangish/red in the night sky, which is very distinctive. It lies in the upper left region of Orion. Since this episode is about Jupiter's moons, I have to mention an amazing opportunity tonight to observe our moon and Jupiter's moons at the same time. Jupiter will lie close to the crescent moon tonight, and therefore Moon and Jupiter's moon will share the view in a telescope. Venus can be found a palm's worth below the duo. An event worth mentioning is the moon's usually hardly seen or visible ocean being visible on February 25th. Mariah named Mare Smythe and Mare Margini will be visible if looked for between Mare Crisium and Moon's Edge. These Mariah, situated on the eastern limb of the moon, are hardly visible and can be seen when lunar libration effects come into play. These effects are caused due to Moon's orbit being inclined as well as elliptical. This is all for this section for tonight. Happy observing, everyone. I will now hand it over to Dorsa to get us started on our topic for today. Take it away, Dorsa.
Thank you, Maheen. Hello and welcome to our TeleTube once again. Today, we're diving into some beautiful natural satellites, or moons, that the biggest planet in the solar system has. Jupiter is known to have 92 moons as of February 2023, very interestingly exceeding the number of moons Saturn currently has. However, Today we will only talk about Jupiter's Galilean moons, Ganymede, Io, Callisto, and Europa. They were discovered by Galileo Galilei, hence giving them the name Galilean moons. These moons are hypothesized to be formed when Jupiter was made out of a disk of dust and gas surrounding our young sun in the Asian solar system. Once this gas and dust had condensed to form this planet, the leftover material or debris coalesced and grew over time to form the Galilean moons. Just like other astronomical objects in our neighborhood, these moons were also formed about 4.5 billion years ago. They have quite a few similarities with one another that would actually like to go over. For example, did you know that all of the Galilean moons are known to each have a radii larger than any of the dwarf planets? They're one of the largest objects in the solar system outside of the 8 planets by mass, with Ganymede being the largest moon in the solar system, even larger than Mercury in terms of diameter. Each of these moons have interesting facts about themselves, making them common targets for scientific research purposes. Io is the most volcanically active body in the solar system, with its name coming from Greek mythology, from a priestess of Hera who became one of Zeus's lovers, or Europa having an icy surface with liquid water underneath that surface, opening doors for research regarding its environment and search for life in general, with its name coming from the mythical Phoenician noblewoman, who was courted by Zeus and who later became the Queen of Crete. Moving on, each of these Galilean moons have their own special geological and chemical characteristics and structures proposed to their environments both on and underneath their surfaces. If they could possibly have an atmosphere or not, showing any sign of life as we know, or if life could be developed there over time, are all the questions that we would like to answer. So all of these questions and many more have the science community interested in conducting research, thus initializing multiple missions to be made and sent to these moons by various space agencies. Further through this talk, my colleagues will go over each of these Galilean moons and their attributes alongside their missions. However, before I pass it on to Marianna, who's going to talk about Io, there is one last fact that I would like to share with you all. The Galilean moons can actually be seen, not too up close though, when observing Jupiter through a telescope. Both of our 1 meter and 40 centimeter telescopes have captured a few images of these fascinating sights, whilst showing how beautiful the fifth planet from the sun is. Interestingly enough, actually, sometimes you can even see the shadows of the moons as they cast on the cloud tops of Jupiter itself. But of course, all of this depends on the geological location that you're at and also the weather conditions. Well, that's all for my part, folks. Giving it to my colleague and friend now. Marianna, take it away.
Thank you, Dorsa. I would like to begin our discussion with Jupiter's Galilean moons by starting with the Galilean moon Io. Io is a little over 422,000 kilometers away from Jupiter and is about 4.5 billion years old, which is around the same age as Jupiter. Io is slightly larger than Earth's moon and has a radius of just over 1,800 kilometers. This moon is tidally locked to Jupiter, meaning that the same side of Io faces Jupiter and does not rotate. This is similar to our moon and Earth. Io is caught in a tug-of-war between Jupiter's massive gravity and the other precisely timed gravity of the two neighboring moons, Europa and Ganymede. The temperature on its surface is around minus 130 degrees Celsius, which forms sulfur dioxide snowfields. However, the volcanoes in Io, which we'll discuss shortly, can reach over 1,600 degrees Celsius. Because of these two huge temperature differences, Io is also referred to as a celestial body of fire and ice. The exact composition of this moon is unknown. However, it is thought to be molten sulfur, its compounds, and silicate rock, according to NASA. And according to ESA, the surface is primarily composed of sulfur dioxide. Along with this, patches of sulfur dioxide frost have been spotted on the surface. Similarly, Io has a sulfur dioxide atmosphere, which is extremely thin, and is about 1/billionth the surface temperature of Earth's atmosphere. Surface pressure of Earth's atmosphere. Although Io is small compared to its parent planet, it has a mighty impact on Jupiter. The orbit of Io cuts across Jupiter's magnetic lines of force, making Io an electric generator that can develop 400,000 volts across itself. As Jupiter rotates, the magnetic force strips away some of Io's materials, and the ions are pulled into Jupiter's upper atmosphere, and it creates auroras. This can be seen in the image on the right side of the slide. This moon is said to have a collapsible atmosphere, meaning that its sulfur dioxide atmosphere freezes up when it's in the shadows of Jupiter, but then converts back to gas once it comes back into sunlight. So it is very evident that this moon truly does have an impact on this gas giant. When looking at images of Io, you tend to see like a yellow, orangey-ish moon with few craters and a relatively smooth surface. This is because Io's tidal forces generate an immense amount of heat within the moon, keeping the subsurface crust in liquid form, wanting to escape to the surface to relieve the pressure. This allows the surface of Io to constantly renew itself, filling in any impact craters with molten lava lakes and spreading smooth new floodplains of liquid rock. The white patches on Io that you see on the image are actually areas of frost made of sulfur dioxide, not water, as mentioned previously. Jupiter's moon Io is also known for being the most volcanically active world in our solar system. There are hundreds of volcanoes on this moon, with some erupting fountains of lava dozens of kilometers high. The composition of the lava on Io is speculated to be of liquid sulfur. No surprise. While no dedicated mission has been sent to Io, several spacecrafts have flown by Jupiter and observed its moons. There are multiple missions that have taken images and made observations of Io with flybys, but not ever actually landing on the moon itself. Voyager 1 caught a volcanic eruption on Io's surface during its flyby of Jupiter, while Voyager 2 took additional images and revealed that the persistence of the volcanic eruptions during another flyby of the moon. NASA's Galileo spacecraft made multiple flybys of Io and provided astronomers with the closest views of this volcanic moon. There are a couple of missions that are set out for the near future to present us with more data and images of Io and other moons of Jupiter. NASA's Juno spacecraft will fly by this beautiful moon and will provide a new perspective of Io which hadn't been explored in detail since the Galileo spacecraft. Juno will study how the heat is distributed across the moon, look for changes of volcanoes, and collect data on whether or not a magma ocean lies beneath its surface. The ESA's Jupiter Icy Moon Explorer, also known as JUICE, will study Jupiter's Galilean moons. While JUICE will not focus on exploring Io in depth, this mission will gather information of how Io helped shape the plasma environment of Jupiter. This would help by characterizing how and why the moon is so volcanically, tidally, and geologically active, and also help to determine the composition of its surface. Finally, there is a proposed Io Volcano Observer mission, also known as IVO. IVO will encounter Io 10 times within 3.5 years and will gather closer insight on what feeds this moon's volcanoes. And although this moon is ever so fascinating and can be talked about for hours, I believe it's time to hand it over to my friend Cam so that she can talk to you about the next Galilean moon.
Thank you, Marianna. I am now going to continue our discussion of Jupiter's Galilean moons by talking about Europa. Europa is named after a lover of Zeus, the Greek counterpart of Jupiter. This moon is about 700,000 kilometers away from Jupiter, and its rotation around the planet lasts 3.5 days. Its orbit is elliptical, which means that the distance to Jupiter changes, and the closest side feels Jupiter's gravity more strongly than its far side. This causes tides that stretch and relax the moon's surface. It is believed that the flexing from the tides creates Europa's famous surface fractures. This moon is locked by gravity to Jupiter, which means that the same hemisphere of the Moon always faces the planet. Interestingly enough, this also happened to Earth's moon. Europa's diameter at the equator is about 3,000 kilometers, and for reference, it is roughly 90% the size of our moon. However, it is 5 times brighter due to a surface made up of ice and water, making it highly reflective. Europa is believed to have an iron core, a rocky mantle, and an ocean of salty water, just like our planet. The ocean on Europa, in contrast to Earth, it is thought to be 60 to 150 kilometers deep and rests beneath a shell of ice that is roughly 15 to 25 kilometers thick. The reason why it is believed that Europa has an ocean is because one of the measurements made by NASA's Galileo spacecraft back when it explored the Jupiter system from 1995 to 2003. It was shown that in the region surrounding Europa, Jupiter's magnetic field was disturbed. A thick layer of some electrically conducting fluid beneath the surface of Europa produces a unique form of magnetic field. Scientists believe that a worldwide ocean of salt water is the most logical source of this magnetic signal, given the composition of Europa. Based on a study on Europa's craters, it was discovered that this moon is young compared to other Galilean moons, since most of them are billions of years old, and Europa was found to be 40 to 90 million years old. There is a reddish-brown substance that runs through all of Europa's fractures. Its exact composition is unclear, but it certainly consists of salts and sulfur compounds that have been combined with the water ice and altered by radiation. Many of Europa's long, linear fractures are only a few kilometers wide, but they can be thousands of kilometers long. While some of these fractures appear to have ripped apart into broad bands of numerous parallel fractures, others appear to have risen up into mountains that are hundreds of meters tall. When it comes to its atmosphere, this moon has a thin layer of oxygen. In 2013, NASA reported that scientists had discovered evidence that the moon may be actively leaking water into space. This would imply that the moon is currently experiencing geological activity. Astrobiologists think Europa has plenty of water and the necessary chemicals ingredient, but confirming an energy source on Europa has proven difficult. To study Europa more in depth, NASA plans to launch Europa Clipper in 2024. A spacecraft whose primary mission will be to undertake extensive exploration of Europa to examine if the icy moon could contain conditions suitable for life. Life forms have been discovered thriving near subsurface volcanoes, deep sea vents, and other severe settings on Earth. If we finally uncover life on Europa, it might resemble microorganisms. If it can be proved that life evolved independently in 2 locations around the Sun, it may be reasonable to think that life rises up easily in the cosmos once the basic elements are present, and that life may be found across our galaxy and the universe. I will continue to talk about Europa's next mission for hours, but I think it is time to give it away to my friend Zena, who will introduce us to the next Galilean moon, Ganymede.
Thank you, Cam, for the informative and interesting piece about Europa. I definitely learned a lot from that. However, I would like to shift gears slightly to talk about another fascinating Galilean moon, which is Ganymede. Ganymede is the largest moon in the solar system. It is also the 9th largest object in the solar system and the largest object without a substantial atmosphere. However, it is not the most massive object, as Mercury holds that title. With a diameter of 5,268 kilometers, Ganymede is 26% larger than the planet Mercury by volume, but it's only 45% as massive. It has a metallic core and is the only moon in the solar system that is known to have a magnetic field. Ganymede is made up of approximately equal amounts of silicate rock and water, and it has a fully differentiated body that is rich in iron, and in addition to a liquid core and an internal ocean that may contain more water than all of Earth's oceans combined. The surface of Ganymede is composed of two main types of terrain, with dark regions saturated with impact craters covering about a third of it, and lighter regions with grooves and ridges covering the remainder. The cause of the light terrain's disrupted geology is not fully understood, but is believed to be due to tectonic activity resulting from tidal heating. Ganymede's magnetic field is most likely created by convection within its liquid iron core, which is created by Jupiter's tidal forces. This moon has a thin layer of oxygen atmosphere that possibly includes O3, which is ozone, with atomic hydrogen being a minor atmospheric constituent. Its name was suggested by astronomer Simon Marius after the mythological Ganymede, a Trojan prince who was carried off by Zeus, Jupiter's Greek counterpart, to be the cupbearer of the gods. On a more historic and scientific note, Ganymede was discovered by Galileo on January 7, 1610. Around 2400 years ago, an astronomer named Gan Di from China might have spotted one of Jupiter's moons, most likely Ganymede, without a telescope. However, he mistakenly thought it had a reddish color, which would not be visible to the naked eye. Later, in 1610, Galileo Galilei used a telescope to observe what he initially thought were three stars near Jupiter. He soon realized that they were actually moons orbiting Jupiter, including Ganymede, Callisto, and the combined light from Io and Europa. He saw all four moons together for the first time on January 13th, and by January 15th, he concluded that they were indeed moons orbiting Jupiter. The names of Jupiter's moons were not commonly used until the mid-20th century, and instead, Ganymede was often called Jupiter III in the earlier literature. Ganymede, along with Io, Europa, and Callisto, are named after ancient Greek mythology characters. These names, or the names of these moons, are spelled in Italian and in English with a final E in Ganymede's name, which is silent. And that is different from later moon names that are taken from Latin and Greek. Multiple missions have been and will be carried to continue to study and explore Ganymede. The first spacecraft to get close to Ganymede was Pioneer 10 in 1973, followed by Pioneer 11 in 1974. Both sent back data and images of Ganymede's surface. Voyager 1 and Voyager 2 also studied Ganymede during flybys in 1979 and provided more data and images, which helped scientists learn more about this moon's size and terrain. However, it was the Galileo spacecraft which entered orbit around Jupiter in 1995 that made the most in-depth observations of Ganymede. Galileo, the spacecraft, made 6 close flybys and discovered the moon's subsurface ocean, and the closest flyby, which was G2, passed just 264 kilometers from the surface of Ganymede. The New Horizons spacecraft also observed Ganymede from a distance in 2007 and performed mapping of its surface. Juno, which orbits around Jupiter, had 2 flybys of Ganymede in 2019 and in 2021, collecting additional images of its surface and polar regions. More missions are planned for the future, and in 2023, which is this year, the Jupiter Icy Moons Explorer, or JUICE, will be launched and will be the first to orbit around Ganymede itself. JUICE is planned to reach the Moon in 2032 and will collect data to help us better understand Ganymede. However, the mission will end in February 2034 when the spacecraft will be intentionally crashed into this moon. Other missions have been proposed, such as the Jupiter Icy Moons Orbiter and the Grandeur of Ganymede, but were either not funded or cancelled before launch. In 2010, there was a proposal to send a Ganymede orbiter based on the Juno probe, but the mission was not supported. Instead, the Europa Clipper mission was preferred. Another mission, the Europa Jupiter System Mission, or EJSM, was a joint NASA and ESA proposal to explore Jupiter's moons, including Ganymede. Although the NASA and the JAXA components were cancelled, the ESA-led Jupiter-Ganymede orbiter part of the mission was still planned to continue. I could talk about Ganymede forever, but now it's time to hand it over to my colleague Pouria to tell us more about another fascinating moon, which is Callisto.
Thank you so much, Zena, and greetings, everyone. My name is Pouria, and I will be your host for your journey through Callisto. Callisto is the second largest moon of the Jupiter and also the third biggest moon in the solar system. It is named after Zeus's many lovers and partners. Based on Greek mythology, Callisto was associated with Artemis, goddess of hunting. Its size is almost the same as Mercury due to having no volcanic activity and tectonic activity. Scientists used to call Callisto an ugly duckling moon and a hunk of rock and ice. But later on, they found out that Callisto is actually made from a salty ocean underneath its icy surface. Callisto was discovered by Galileo on January 7, 1610, along with three other moons named Ganymede, Io, and Europa. Callisto has a diameter of about 4,800 kilometers, which is 100 kilometers smaller than the diameter of the planet Mercury, and it orbits the Jupiter in diameter of about 1,889,000 kilometers, and Jupiter rotates around the Sun a distance of 778 million kilometers. As a fact, I also have to say that Earth rotates around the Sun from a distance of 150 million kilometers. Callisto rotates around the Jupiter 1.8 times farther away than Ganymede, 2.8 times farther than Europa, and 4.5 times farther than Io. The density of the Callisto is 1.83 grams per cubic centimeter, which is a little more than our moon's density. Scientists believe that Callisto and other moons of Jupiter were made from the components of Jupiter's rings. The interior of Callisto is half made of rocks and half is made of a salty ocean beneath the icy surface. In the whole solar system, the surface of Callisto is the oldest and the most cratered. The surface has an age of about 4 billion years old, which is quite old, but this is almost nothing in age scale in astronomy and physics. The reason that scientists believe that Callisto doesn't have any geologic activity is because that the craters are heavily visible and there's a lot of them on the surface unchanged. In 1999, scientists found out that Callisto has a very thin atmosphere made from carbon dioxide and a little bit of oxygen. As you can see on the right of the screen, you can see a concept art about how living in Callisto could look like. The scientists believe that the ocean that presumably exists inside the moon might be 250 kilometers beneath the surface. But in recent researches, it is believed that the ocean is deeper than before, or even it might not exist. Considering that there is oxygen on Callisto and there might be a salty ocean, Callisto is put on the list that there might be a life in there. In the case of exploration, there were many attempts to get information about Callisto, Pioneer 10 and Pioneer 11 being the first missions in exploring Callisto. But the most important findings were when Voyager 1 and Voyager 2 flew past by Callisto. They took wide images of the surface of Callisto, if I want to approximate, almost about like 1 to 2 kilometers of images, and measured the temperature, mass, and shape. Also, from 1993 to 2003, the Galileo spacecraft had close bys to Callisto. In 2000, also in 2000, Cassini spacecraft had some detailed information about this moon, and in 2007, the New Horizons spacecraft got new images from Callisto on its way to Pluto. The next planet close by to Callisto, as my friend Zena said, is by ESA's Jupiter's Icy Moon Explorer, or JUICE, which is going to be launched on 2023. Now that we're finished with all the informations, I would like to give it to my friend and co-worker Marianna for the outro. Marianna, please take place.
Well, everyone, you have been listening to the Allen I. Carswell Observatory's weekly TeleTube broadcast, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Maheen, Dorsa, Cam, Zena, Pouria, and myself, Marianna. Make sure to leave any comments or questions in the comment section of the video and talk to us in chat right now. We'll be around for the next 20 minutes or so to answer any of your questions. All of our programs are free, but if you would like to make a donation, see our website at yorku.ca/science/observatory. You can always connect with us on Twitter with the handle @YorkObservatory and check out our website for show notes, content, update, and contact information at yorku.ca/science/observatory. Thank you for tuning in, clear skies, and have a great night.